Good morning, my dear students. Today we are going to theorem number 4, that is derive the condition for coplanarity of two lines. So very important this theorem, all of you thorough this one, theorem number 4. So statement they have to ask in exam, derive the condition for coplanarity of two lines in space, both vector and Cartesian form. Both vector and Cartesian form. So this is very important theorem. How to derive this one? To derive this theorem, we have to follow the geometrical figure. That is, let us take three-dimensional geometry, 3D space. X-axis we can take here. Generally y-axis, x-axis, z-axis. Let O be the horizon. Now let us take plane. Plane nothing but what? Surface. We have to take the surface like this. This is denoted by pi letter. I consider two lines. So let us take, let the two lines we have to consider. What is the equation of a line in the equation of a line? Standard form, R bar is equal to A bar plus lambda times B bar. This is called equation of a line in vector form, passing through the point and parallel to vector B. But I have to take two lines. So A1 bar plus lambda times B1 bar as equation number 1. And also, and R bar is equal to A2 bar plus mu times B2 bar as equation number 2. What is the meaning of equation 1? It means, just I am writing equation 1, this one, passing through the point. Which point here? A point. Passing through, shortly I am writing like this, point A. Let us take x1, y1, z1 with position vector. This is called position vector of OA. With position vector, okay, A bar, A1 bar, and is parallel to which vector? Parallel to B1 vector and parallel to B1 bar. Similarly, equation 2 also passing through the point A2 vector, that is. So we are writing equation 2 passing through, equation 2 passing through point B. Point we have to take x2, y2, z2, okay, with position vector, with position vector. What is the position vector? A2 bar and parallel to which vector? And parallel to B2 vector. Okay, this is about equation 1, equation 2. Now I am taking these two lines on the space. I have to take line, this is L1. So L1 line, this is equation number 1, that is. As equation number we can take another line. These two lies on the both are actually coplanar. Coplanar hangandre ಏನು? lie on the same plane. So I am taking one more line like this. This is the line L2. Line L1 passing through which point? Passing through which point? A. So I have to put A point here. What is the point here? X1, Y1, Z1. X1, Y1, Z1. And this line also parallel to which vector? B1 vector. I take the B1 vector. This is the B1 vector, which is parallel to L1 line. And line L2 passing through which point? B, that is A2 vector. So that is, this is passing through the point B, X2, Y2, Z2, and which is parallel to B2 vector. I take the B2 vector. This is parallel to which line? L2 only. And now joining OA vector. So we get position vector OA, that is A1 bar. Join OB, we get this is A2 vector. Okay. So this is A2 vector. Now join AB. This is AB vector. From this is called, if I join like this, what is the getting? OAB is a triangle. So from the triangle OAB, using vector law of addition, using triangle law of vector addition, OA bar plus AB bar is equal to OB bar. AB bar equals OB bar minus OA bar. This means AB bar equals OB bar is what? A2 vector minus OA bar is what? A1 vector. So we got AB vector is equal to A2 bar minus A1 bar. Now what are the B1 and B2? These are the parallel vectors of line L1 and L2 respectively. What is the vectors of two vectors? Vector of two vectors always nothing but cross product. Where does it lie? Cross product of B1 and B2. So B1 and B2, it lies on the plane only. Okay, that is perpendicular to the plane. So I will show the perpendicular condition like this. So this is B1 bar cross B2 bar, which is perpendicular to the plane. Okay, we have to throw it in three-dimensional space. We are using only one technique. That is what? Which technique we are using? Dot product will be 0. Why? Because here, since two lines are L1 and L2 lines are coplanar. So since L1, that means two lines, since given lines are coplanar, it means what? Vector B1 cross B2 is perpendicular to what? AB. Why? Because AB lies on the plane. AB lies on the plane, along the plane. So it is perpendicular to the plane, means it is perpendicular to AB vector. That is AB vector is perpendicular to B1 vector cross B2 vector. That implies AB vector, I can write here, AB vector dot B1 cross B2 vector is equal to 0. This implies A2 bar minus A1 bar dot B1 cross B2 bar is equal to 0. So this is the condition for coplanarity of two lines in vector form. In vector form, this is the condition. What is the condition in vector form? A2 bar minus A1 bar dot B1 cross B2 is equal to 0. A2 is what? Position vector of the point B. A1 is what? Position vector of the point A. B1 cross B2. This is perpendicular to the plane. Same technique we have to use. Everywhere same technique. From this we have to derive in the Cartesian form also. So how to derive Cartesian form? Very simple Cartesian form. So let us take, what is the A2 vector? Take here, let A1 vector is equal to x1, y1, z1, write in vector form, x1i plus y1j plus z1k. A2 vector is equal to B point x2i plus y2j plus z2k. Hereafter consider drs of B1 and B2. Let us take, let A1 B1 C1 and A2 B2 C2 are direction ratios of B1 vector and B2 vectors. So these are the vectors, these are the numbers. Don't forget here, these are not same. These are the direction ratios of B1 vector, means line L1. These are the direction ratios of B2 vector. These are vectors, these are the numbers, clearly remember. Hereafter we have to find A2 bar minus A1 bar. Now A2 bar minus A1 bar, that is equal to, shall we write directly? Okay, number of questions we done like this. So subtracting from A2, x2 minus x1 into I, x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. This is the A2 vector. A2 vector minus A1 vector. Now we are going to substitute in the equation 1. So instead of that is, directly we have to write in the matrix determinant form. So using this, if you are writing here, this is very big. So to remember that is, it is very difficult. So instead of that, so substitute in equation 1, write in matrix form, determinant form. Substitute in equation 1, determinant of first row, A2 minus A1 vector coefficients, x2 minus x1, y2 minus y1, z2 minus z1. Hereafter B1 vector drs, write the second row A1 B1 C1 and third row A2 B2 C2 is equal to 0, determinant equal to 0. So this is called condition for Cartesian form. Okay, which is condition for coplanarity of two lines. So remember all of you, condition for coplanarity of two lines, very very important theorem, very easy to solve this question. So derive the condition for coplanarity of two lines means, take the two lines in the vector form. R bar is equal to A1 bar plus lambda times B1 bar. R bar is equal to A2 bar plus mu times B2 bar. 1 means here passing through the point A and parallel to B1 vector. Equation 2 means passing through the point B parallel to B2 vector. So join position vectors are getting, find out triangle of vector addition. AB vector is equal to A2 bar minus A1 bar. Since lines are coplanar, means lie on the same plane. So AB vector is perpendicular to B1 cross B2. Why? Because this B1 cross B2 always lie on the, that is perpendicular to plane always. So you remember this law always. I, J, K. So this J and K perpendicular to I vector always. So perpendicular to this one. So now dot product will be 0. So dot product applying A2 bar minus A1 bar dot B1 cross B2 will be 0. From this we have to derive the Cartesian form. Very simple. A1 vector, A2 vector and drs taking. Then after substitute in equation, write directly in matrix determinant form. Determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 equal to 0. These are the main theorems in the planes chapter. Now we are going to remaining, those are the formulas. What are the formulas? One by one. Now continue, that is next part, intercept form. Now onwards you remember the formula enough. So intercept form. So what is the equation of a plane in the intercept form? Remember all of you, equation of a plane. We studied in the lower classes. Intercept form, equation of a line in two-dimensional geometry. X divided by A plus Y divided by B is equal to 1. Here in three-dimensional geometry, we added Z coordinate. So that is X divided by A plus Y divided by B plus Z divided by C equals 1. You remember intercept form of a plane equation. Okay, A, B, C. A is called x-intercept, B is called y-intercept, C is called z-intercept. Derivations, no need. We have the derivations, but maximum these are only important. Now these are useful for the formulas to solve the questions. Next question, next one, different forms. Equation of a line. Equation of a line passing through. Equation of a line passing through point of intersection of two planes. Two planes. This is the next concept. So here you remember only formulas. So this is the plane. We take the plane here, plane 1. And another plane. So let us take, this is the plane 1, plane 2. These two are intersecting at these 2 points. So this line of intersection is required. So what is the line of intersection of pi 1 and pi 2? This line of intersection and this one. So this is, what is this plane equation we want, pi 3. So no need these all concepts, derivations, just you remember what is the formula. According to this, what is the equation of a plane passing through line of intersection of 2 planes, pi 1 and pi 2. So remember simple formula, required plane equation. Equation of a plane in vector form. First I am writing. First one, vector form is short form, remember, first plane plus lambda times pi 2 is equal to 0. This is the vector form of a plane equation passing through point of intersection of 2 planes. If we want really, that is plane equations, we know that. What is the equation of a plane? R bar dot n bar is equal to d. Okay, n is the only normal vector, but their normal form is n cap, that is. So normal vector only take here. So that is r bar dot n1 bar plus lambda times n2 bar equals d1 plus lambda times d2. This is the vector form of plane equation passing through line of intersection of two planes. In 2D also, two dimensional in straight lines, L1 plus lambda times L2 is equal to 0. So we derived like this. But here derivations, no need. We should use this formula, very important, for 3 marks. In problem 3 marks questions, problems only they are asking. Now I am going to second one is Cartesian form. Cartesian form is Cartesian form, remember what is the Cartesian form plane equation? Ax plus by plus cz is equal to d like this, or d1 plus d is equal to 0, whatever it is, this is the form. So here also how to write, two planes I am taking is ax plus, that is a1x plus b1y plus c1z plus d1 plus lambda times a2x plus b2y plus c2z plus d2 is equal to 0. This is called equation of a plane passing through line of intersection of two planes in Cartesian form. Remember all of you, these two formulas very important. We have to solve the questions in exercise. Next we are going to, next point is angle between two planes. Angle between two planes. So how to define? Here also vector form, Cartesian form, I take the two planes. Plane 1 I am taking r bar dot n1 bar is equal to d1, and pi 2 r bar dot n2 bar is equal to d2. Here simple constant and normal vector is given. So let theta be the angle between them and theta be the angle between them. Then vector form, first one I am taking vector form. So that is how to define, means a simple. So I am taking the plane, this is the first plane, okay, pi 1. And another plane I am taking, this is the second plane. So angle is formed only, intersection lines are intersection planes. Here planes are given, this is the pi 2 plane. So I am taking, these are intersecting at this point anywhere here. This is the first I am taking, this is the normal vector to the first plane n1 bar. And for this plane I am taking, this is the n2 bar, normal vector to the second plane. These are perpendicular to the plane 1 and this is perpendicular to plane 1, this is perpendicular to plane 2 also. So this angle between two normals, angle between their normals is equal to angle between two planes, remember. So whatever it is, so vector form I am writing. So vector form, cos theta is equal to formula, remember, cos theta is equal to n1 vector dot n2 vector divided by magnitude of n1 vector into magnitude of n2 vector. So derivations here, leave it, simply we remember what is the vector form. Angle between two planes in vector form, cos theta is equal to n1 vector dot n2 vector divided by magnitude of n1 vector into magnitude of n2 vector. In Cartesian form, so what is the angle between two planes? So in Cartesian form, remember cos theta is equal to two planes in Cartesian form. Like this only, these are Cartesian plane equations. So dot n1 vector dot n2 vector means product value. So a1 into a2, a1 a2 plus b1 b2 plus c1 c2 upon square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. This is the angle between two planes in Cartesian form. So Cartesian form, vector form. In this case, we are using conditions also. Conditions are, if theta is equal to 0 degrees, then what happen? Planes are parallel. If two planes are parallel means angle is 0. Then condition becomes, if you simplify that, a1 by a2 is equal to b1 by b2 equals c1 by c2. Here I am writing, continue the condition. Third one is condition I am taking. Third one condition I am taking, that is condition, that is if theta is equal to 0 degrees, then condition a1 by a2 equals b1 by b2 equals c1 by c2. It means, remember all of you, pi 1 and pi 2 planes are parallel. These are parallel planes, meaning pi 1 and pi 2 planes are parallel. Similarly, fourth condition, if theta is equal to 90 degrees, 90 degrees hangandrenu, it means theta equal 90 means it becomes 0. Okay, that means planes are perpendicular. So that is condition becomes a1 a2. If theta equal 90 degrees, condition will be a1 a2 plus b1 b2 plus c1 c2 equals 0. This meaning pi 1 and pi 2 planes are perpendicular. Keep in our mind these two conditions, very very important. And next one, distance point, distance model also very very important. Distance concept. Okay. So distance model formulas, see here all of you how to find out. Distance formula, distance of a point from plane, distance of a point from plane only. So this is very important, this is also. Okay, I am taking here plane, here I am taking point is any point P, x1, y1, z1. Okay, or A, whatever it is, we can take the point here. I will show the diagram simply. This is the plane equation. This is the point here A. From the point A to plane, perpendicular distance asking, plane pi. So here with position vector, always that becomes A bar. So here distance formula in vector form. First one in vector form, remember. Vector form, plane equation pi ax plus by plus cz is equal to d, or minus d is equal or plus d equal to 0. This is also nothing but r bar dot n bar is equal to d. R bar dot n bar is equal to d. Okay, ax plus by plus cz is equal to d, meaning this is in Cartesian form, this is in vector form. Now I want distance formula in vector form. D is equal to capital D, meaning I should take distance of a point from the plane. that is magnitude of, okay, a bar dot n bar minus d, a bar dot minus dot n bar minus d divided by magnitude of n bar. This is the distance of a point from a plane, okay, any point that is x1, y1, z1. So this is the point. Remember, in Cartesian form, distance formula d is equal to a into, substitute here dot product, it becomes, here only substitute a into x1 plus b into y1, a into x1 plus b into y1 plus c into z1 minus d divided by square root of a square plus b square plus c square. These are the normals. Now this is the formula in vector form and Cartesian form. To find the distance of a point from the plane in vector form, magnitude of a bar dot n bar minus d upon magnitude of n bar. In Cartesian form, distance formula, magnitude of ax1 plus by1 plus cz1 minus d upon square root of a square plus b square plus c square. You have seen this, haven't seen this one? Yes, in two-dimensional geometry, distance, perpendicular distance formula, magnitude of ax1 plus by1 plus c or minus c divided by square root of a square plus b square. Here also little same, but z coordinate is added, that is only difference. Suppose if origin given, if the point becomes origin, from the origin, what is the distance? This point becomes 0. From the origin, distance equal to formula. So here you remember, note, if given origin, from origin to the plane, distance formula, this becomes 0, magnitude value, that is magnitude of d divided by magnitude of n vector. Here if you substitute 0, x1, y1, z1, 0, it becomes here distance in Cartesian form, magnitude of d divided by square root of a square plus b square plus c square. What are the ABs actually? DRs of plane. ABC are called normals, that means DRs of a normal line to the plane. This is the distance model formulas from any point from origin also. Keep in your brain these formulas. You also revise number of times. I repeated number of times these things. Vector form. Distance of a point, any point from plane is magnitude of a bar dot n bar minus d divided by magnitude of n bar. From origin, d is equal in vector form, magnitude of d by magnitude of n bar. In Cartesian form, distance formula, magnitude of ax1 plus by1 plus cz1 minus d by square root of a square plus b square plus c square. In from origin, d equal to magnitude of d by square root of a square plus b square plus c square. And then last point here, that is next point here, angle between line and plane. For entrance point of view, this is very, very important. In both vector and Cartesian form, he is asking here angle between line and plane. So let us see, this is the plane and line, any line here. So I am taking here, what is the line here? Plane equation is pi. Pi is equal to r bar dot n bar is equal to d. Line is denoted by L, that is r bar is equal to a bar plus lambda times b bar. So b is what here? That is normal. So normal vector. N bar is what here? Normal to the plane. So this is normal to the plane, this is the line only. So this is normal vector, and line is parallel to which one? B vector. So I am taking B vector like this. This is the B vector. Asking this angle, what is the angle between line and plane? This is nothing but here this is perpendicular. This is how much angle? 90 degree. This angle becomes what? This angle equal to 90 minus theta. This is the angle between line and plane. So 90 minus theta is also called complementary angle. So complementary angle is called angle between line and plane. So here if you substitute 90 minus theta in this formula, cos 90 minus theta becomes sin theta. Now in vector form, I am taking here vector form formula. Sin theta is equal to n bar dot b bar divided by magnitude of n bar into magnitude of b bar. This is the angle between line and plane in vector form. But generally we are using Cartesian form in entrance point of view. What is the angle between line and plane in Cartesian form? In Cartesian form, let us take n vector. N vector is what here? What are the drs? A, B, C. This is B vector. It has also drs, direction. Let us take L, M, N. So we can take L, M, N are the here also drs. Then sin theta formula AL plus BM plus CN divided by square root of a square plus b square plus c square into square root of L square plus M square plus N square. But in this case, L, M, N are drs. Okay, I took here for our convenient letters taken. L, M, N are drs of a B vector in line, and A, B, C are drs of a plane of n vector. Then sin theta is equal to AL plus BM plus CN divided by square root of A square plus B square plus C square into square root of L square plus M square plus N square. Here also we have the conditions. Remember third one, if line and plane are parallel, that means if theta is equal to 0 degrees, sin 0 is 0. Okay, na? Sin 0 is 0. We are getting AL plus BM plus CN equal to 0. So here condition form, remember, AL plus BM plus CN equal to 0. This means plane parallel to line. Plane and line are parallel. Here condition is reversed. Here condition is what? A1 by A2, these are the condition, parallel condition. But here condition is reversed. AL plus BM plus CN equal to 0. Third one, fourth one, if theta is equal to 90 degrees, then condition becomes A divided by L equals B divided by M equals C divided by N. This means plane is perpendicular to line L. If plane and line are perpendicular, we have to use A by L equals B by M equals C by N. If plane and line are parallel or coincide, we should use AL plus BM plus CN equal to 0. This is the whole formulas concept in the planes. Once again formula say that the first one, equation of a plane in the normal form. Equation of a plane in the normal form is first theorem, r bar dot n cap is equal to d. In Cartesian form, Lx plus my plus nz is equal to d, where d is the perpendicular distance from horizon to the plane, perpendicular distance of a plane from the horizon only. L, M, N are direction cosines. What is the general form of a plane equation? General form of a plane equation in vector form, r bar dot n bar equal to d. Okay, here n bar is the normal vector only. There n cap is normal unit vector. D is the here small simple constant. but their perpendicular distance of a plane from the horizon only. That is the difference. Second one, equation of a plane passing through the point and perpendicular to the vector. That is second theorem. In vector form, a bracket x minus x1 plus b bracket y minus y1 plus c bracket z minus z1 equal to 0. In Cartesian form, what is the Cartesian form here? That is in Cartesian form only. Vector form is r bar minus a bar, that is r bar minus a bar dot n bar equal to 0. Cartesian form is a bracket x minus x1 plus b bracket y minus y1 plus c bracket z minus z1 equal to 0. Third one, equation of a plane passing through three non-collinear points, that is given, okay, using matrix determinant form. Remember, determinant of first you write x, y, z, second row x1, y, x2, y2, z2, third row x3, y3, z3, subtract in first column x1, in second column x2, y1, third column z1, we are getting is equal to 0. That is the equation of a plane passing through three non-collinear points. Next, derive the condition for coplanarity of two lines. Here also you remember theorem, practice, but remember here for the problem solving we have to use this answer. Determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 equal to 0. Very important condition this is. Next, intercept form. X by a. You also read number of times along with me. Equation of a plane in the intercept form is x by a plus y by b plus z by c is equal to 1. Okay, na friends? Now, equation of a plane passing through the point of intersection of two planes. This plane we want. That is short form, sweetest form, pi 1 plus lambda times pi 2 equal to 0. In vector form like this, r bar dot n1 bar plus lambda times n2 bar equals d1 plus lambda times d2. Cartesian form is a1x plus b1y plus c1z plus d1 plus lambda times a2x plus b2y plus c2z plus d2 equal to 0 is equal to 0. Remember. Next, angle between two planes, vector form, cos theta equal to angle between two planes meaning angle between their normals only, normal vectors, nothing but angle between two planes. Definitions no need, just explain to you. Vector form, cos theta is equal to n1 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. In Cartesian form, cos theta dot product a1 a2 plus b1 b2 plus c1 c2. If you take acute angle meaning magnitude, square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. Here conditions are remembering. First condition, if two planes are parallel, the condition will be a1 by a2 equals b1 by b2 equals c1 by c2. If two planes are perpendicular, a1 a2 plus b1 b2 plus c1 c2 equals 0. In lines also same concept will be there. Next, distance of a point from the plane only. So in vector form, distance formula, magnitude of a bar dot n bar minus d divided by magnitude of n bar. In Cartesian form, distance formula, we know very well, this is remembering and easy also. Magnitude of ax1 plus by1 plus cz1 minus d upon square root of a square plus b square plus c square. A square plus b square plus c square. Suppose instead of point horizon given, what is the distance? In vector form, horizon formula, distance formula, magnitude of d by magnitude of n bar. In Cartesian form, magnitude of d by square root of a square plus b square plus c square. What is the angle between line and plane? For entrance point of maximum time, here 95% here from this only they are asking. Angle in JEE main also same model questions are there. They would have asked that. So here theta, that is, this is the angle theta, this is 90 minus theta. 90 minus theta is called angle between line and plane. That is called complementary angle. Complementary angle is called a angle between line and plane. Derivation only. So vector form formula, sin theta equal to, here cos theta, here sin theta, 90 minus theta. Cos 90 minus theta is sin theta. N bar dot b bar by magnitude of n bar into magnitude of b bar. You also number of times you should read like this. Cartesian form, sin theta is equal to AL plus BM plus CN. Remember all of you here, A, B, C are drs of a plane only, n vector. Lmn also here I have taken here drs. Don't forget here dr. These are not DCs. Sin theta equals AL plus BM plus CN divided by square root of A square plus B square plus C square into square root of L square plus M square plus N square. Remember, this is not a 1. These are the drs. Here conditions. If theta is equal to 0 degrees, the condition will be AL plus BM plus CN equal to 0. That means plane and line are parallel. If plane and line are parallel, condition remember here, AL plus BM plus CN equal to 0. Okay? Number of times you remember this condition. If plane and line are perpendicular, that is A by L is equal to B by M equals C by N. Okay? Okay friends, so today I discussed all formulas in both vector and Cartesian forms. You should thorough all these. Next class we are going to the exercise problems. Okay, thank you.